This video is about the graphs of rational functions. So that's a function where we have a fraction or a divide involved. So we're going to start with the most simple of the rational functions, y equals 1 over x, and we're going to look at what that graph looks like to begin with. And we're going to do so with a table of values. So on the left-hand side here, you can see that I've selected a range of values of x from -4 all the way up to 10, and then I've worked out the equivalent y values for each of those by doing y equals 1 divided by that number. So 1 divided by -4 is minus 0.25, and so on. And then on the right hand side you can see that I have plotted those onto the graph. So that's the rough shape of y equals 1 over x. There's a couple of really important features that I want to talk about though. First of all, you'll notice on the left hand side here there is a big gap here where x is equal to 0. And that's because this function is not defined when x equals 0. If I tried to substitute 0 into this function, if I tried to do 1 divided by 0, well, I can't do it, it's undefined. It doesn't make any sense to say dividing by 0. It doesn't make any sense to share 1 into 0 parts. So we cannot do 1 divided by 0. This function is undefined when x is equal to 0. So quite often what you'll see is it will say next to the function that x cannot equal 0. Now, in terms of what that will be on the graph, there is going to be what we call an asymptote when x equals 0. Now, an asymptote is a straight line that we mark on dotted onto the graph. So this is the line where x equals 0. And this is the vertical asymptote for this graph. The equation of that line is x equals 0. So an asymptote is a straight line that the curve gets closer and closer and closer towards, but never actually touches it or crosses it. So you can see that the blue line here gets closer and closer and closer to the asymptote, but never actually touches it. The same in the negative direction, it gets closer and closer and closer to the asymptote, but doesn't touch it. Now, x equals 0 is the vertical asymptote for this graph. There is also a horizontal asymptote that I'm going to mark on here. And the equation of this asymptote is y equals 0. And again, you can see that my blue line here gets closer and closer and closer to that asymptote, but never touches it. Similar in the negative direction, it gets closer and closer and closer to that red line, but doesn't touch it. The reason why it has y equals 0 as an asymptote is because the y function here, it can never be 0. There is no number that I could substitute in here instead of the x so that I do 1 divided by that number and I get 0. It's impossible to divide 1 by a number and to get 0. So the y can never equal 0 here, and also the x can never equal 0. Now these asymptotes are really important. We always draw the asymptotes with these rational function graphs first. That's the key thing. Right, let's have a look at some slightly different graphs. So on the left-hand side here, I've already drawn the graph y equals 1 over x. You can see I've already marked in my vertical asymptote here and my horizontal asymptote here. And here is the graph of 1 over x, just like we drew on the previous page. Now the graph of 2 over x will be exactly the same, but all the y coordinates will be twice as big. So it's going to have the same shape, it's just all the y coordinates will be higher, be 2 times higher. If I was going to draw 5 over x, well again, it's just going to be exactly the same, just higher. All the y coordinates will be 5 times bigger now. On the right-hand side, you notice here, I want to draw the graph of y equals minus 1 over x. So that's going to have the same shape, but where the y coordinates were positive previously, they're now going to be negative. And where the y coordinates were negative previously, they're now going to be positive. So it would look like that. The minus 2 over x would be the same shape, but all the y coordinates would be 2 times bigger. So like that. If it was 1 over x squared, well, it's still going to have the asymptotes. I'm still going to have an asymptote at x equals 0, because I'm still not allowed to do 1 divided by 0 squared. And it's still going to have a horizontal asymptote at y equals 0, because again, there is no number that I can divide 1 by and get 0. And it's going to have the same sort of shape. The difference here, though, is that when the x coordinates are negative, so where the x coordinates were negative over here, me squaring it will make the y answers positive. So the whole graph is positive. The y coordinates here are positive as usual, and the y coordinates here are positive as well. So that's what the graph of y equals 1 over x squared looks like. The graph of y equals minus 1 over x squared still has my asymptotes in the same place, but this time it's always going to be negative. And again, if I wanted to draw the graph of y equals minus 2 over x squared, that would have the same shape, but all the y coordinates would be 2 times bigger. So it looks something like that. Right. Getting a little bit harder now. Y equals 1 over x minus 5. Now, let's talk about these asymptotes here. Remember that I cannot divide by 0. This denominator is not allowed to be equal to 0. I can't do 1 divided by 0. So if this can't equal 0, so if x minus 5 is not allowed to be equal to 0, then x is not allowed to be equal to 5. I can't substitute 5 in here, because if I did, I'd do 1 divided by 0. So this function is not defined when x is equal to 5. So that is where my vertical asymptote is now. The horizontal asymptote, well, that's still at y equals 0. And the reason for that is, again, 1 divided by a number, this can never equal 0. When I do 1 divided by something, that whole thing can never equal 0. So that's why the y equals 0 is an asymptote. Right, to draw this graph in, I know it's going to look something like this. On the right-hand side, and on the left-hand side, it's going to look something like this. Now you'll notice here that I can actually work out this y-intercept, where it intercepts on the y-axis. Previously, we didn't need to work out that intercept because the graph never intersected on either of the axes. But it does now, so I should work out that coordinate. I know at this point here, I know that x is equal to 0. So if I substitute that into my function, I find that y is equal to 1 divided by 0 minus 5, or 1 divided by minus 5, which is minus 0.2, or minus 1/5. So that is my y-intercept that you should mark onto your sketch. Next. Y equals 3 over 2x plus 1. Right, my vertical asymptote. The denominator here cannot equal 0. So 2x plus 1 is not allowed to equal 0. So 2x is not allowed to equal minus 1. And x is not allowed to equal minus 1/2. So that is my vertical asymptote when x is minus 1/2. My horizontal asymptote is still going to be y equals 0. And the reason why it's still going to be y equals to 0 is because 3 divided by anything, that can never equal 0. Again, you can have any number on the bottom here at all, and when I do 3 divided by that number, this will never equal 0. So to draw the line in, it's going to look like this. The y-intercept here, I know x is 0 at this point, so if I substitute 0 in here, I find that y is equal to 3 divided by 2 times 0 plus 1, so the y-coordinate there is 3. Right, 2 more examples. My vertical asymptote, x can't equal minus 3. This is not allowed to equal 0, so x cannot equal minus 3. So let me draw my vertical asymptote in at x is equal to minus 3. Now, in this case, my horizontal asymptote is going to be at y equals 2. And the reason why that's going to be the case is, I know that this can never equal 0. There is no number that I can do 1 divided by to get 0. So this will never equal 0. Therefore, when I add 2 to that, it can never equal 2. So that's why y equals 2 is my asymptote. I can now draw in my graph. And you can see now that I've got two intercepts I need to work out. First of all, I need to work out the intercept on the y-axis, and then I'm also going to have to work out the intercept on the x-axis as well. So on the y-axis, I know that x equals 0 there. So if I substitute 0 into my function, here I get y is equal to 1 over 3 plus 2, which is 2 1/3, or 7 over 3. At this point here, I know that y is equal to 0. So if I make y 0 here, and then rearrange this equation to solve, I find that x is minus 3.5. And there we go. Right, one more graph to do. And you'll notice in this case, this is an improper fraction. Because I can divide here, I can divide my 4x plus 1 by the x minus 2. So we're going to do a quick bit of algebraic division here, so that I can write this in a simpler form. X goes into the 4x 4 times, and then multiplying out, the 4 times the x is 4x, the 4 times the minus 2 is minus 8, taking that away, we see that our remainder is 9. We know that's a remainder because x is not going to go into the 9. So when we do this division, it goes in 4 times as the whole part, and then the remainder is 9. So I can rewrite the 4x plus 1 over x minus 2 as 4 plus 9 over x minus 2. I can now see that my vertical asymptote is when x equals 2. And my horizontal asymptote is when y equals 4. Because of this. And I can then draw it in here and here. And then I can work out the intercept here because I know that's where x is equal to 0. So if I substitute 0 in to here and here, that's going to give me 1 divided by minus 2, which is actually minus 1/2. So actually I should have drawn this to cut through at minus 1/2. So it should actually have looked a bit more like that. And then at this point here, I know that's where y is equal to 0. So if I take my equation and make that y equals to 0, I can then times by the x minus 2 to get 0 equals 4x plus 1. So x is minus 1/4. And there we go. So key things are, with these graphs, are the asymptotes. We can find the vertical asymptotes by looking at the denominator. We can find the horizontal asymptotes by looking at that number there.